Now before we actually start with glycogen metabolism, just let us revise what you studied in the chemistry part. Okay, so you already studied glycogen. So what was glycogen? Where did we classify it in the classification? Yes, it is a homopolysaccharide. It's a polysaccharide. Okay, first of all, polysaccharide. What kind of a polysaccharide is it? It is a homopolysaccharide. Now what do you mean by homopolysaccharide? Means the repeating units are going to be the same. What are the repeating units? The repeating units are glucose, right? Now it is a polysaccharide, that means there is going to be a long molecule, there is going to be linkage. So what is the linkage? It is alpha 1,4 and alpha 1,6 linkages are going to be there, right? Now next thing that you have to know is that where is this glycogen present? It is present in the liver and the muscle, right? But see, if you are going to be considering the glycogen storage as compared to the liver and the muscle, obviously the glycogen storage is going to be more in the liver than in the muscle. But when you are going to be taking in totality, what you would find is that muscle glycogen is more. Now next thing is that you need to know is that what is the function of this glycogen? The function of this glycogen, is it the same in the liver and in the muscle? No, it is different, right? So what is the function of the liver glycogen? The function of the liver glycogen is to regulate the blood sugar level. Now when you say regulate means what? That means whenever the blood sugar level is going to go down, it is going to be taken care of, or whenever it shoots up also, in that case, both the cases, it's going to be taken care of by the liver glycogen. Muscle glycogen, it is going to be providing energy, right? So these are the two functions of this. Now let us see how this glycogen is going to be synthesized. So the structure of glycogen. So you know that there is a glycogen primer and the glucose units are what are going to be attached, right? So you know that glucose is the molecule which is going to be attached. So now you can see here, this is the structure that we have to draw, right? So these circles are nothing but the glucose molecules, and in between you have the linkage. So here you have the alpha 1,4 linkage, and there you have the branching. There you are going to be having the alpha 1,6 linkage, right? Now how is glycogen going to be synthesized? Obviously, what is the raw material? It is glucose molecule. So glucose is going to be added. Now which kind of glucose molecule is going to be added? The activated glucose molecules are going to be added. And who is going to do it? The enzyme name is, now what are you synthesizing? You are synthesizing glycogen. So what is the molecule that is enzyme that is going to be that is going to be responsible? The name of the enzyme is glycogen synthase. And what is this going to do? It is going to add the activated glucose molecules at the non-reducing end. Okay, so where is it going to add the glucose molecules? It is going to add the glucose molecules at the activated end, and there you are going to be having say around 11 to 12 molecules being added, and then there is another enzyme. So till 11 to 12 molecules are added, this glucose molecule will keep on being added. And what is the name of the enzyme? Glycogen synthase. Now after that is done, there is an enzyme called as branching enzyme. So here the word branching, how do you remember? So glycogen synthesis, then branching enzyme. Now branching enzyme, what is this going to do? It is going to pick up say 6 to 8 molecules, and it is going to transfer it to the other end, right? So that is a branching molecule.